All right, chicken levels, we're good. Hello, hello. Welcome back. It's been a hot minute since I've been in the seat, but here we are, we're back. Welcome to the stream. It's nice to see you. If it's your first time tuning in, I'm Agent Ultra. And on this stream, I program mostly in Haskell, do some functional programming. Well, we build kind of like intermediate level projects to see what it's like to really program in Haskell and use it for everyday programming tasks. Lately, we've been working on a game called LambdaTrek. It's a roguelike style game, kind of based off of the Trek universe. It's inspired by that. If you don't know what it looks like yet, you haven't seen it, let's just boot up a little demo. You'll have to be a little bit patient with me tonight. I'm getting over a cold, so hopefully feeling good now, but a little remnants here and there. Anyways, this is what the project looks like. We're going to run LambdaTrek. Here, it's a terminal-based UI right now. We might port it to a more graphical terminal-ish backend later on, but for now, easy prototyping, super fast, great stuff. If you don't know, the library's called Brick. You want to look it up. It's a great little library. Anywho, this is our starting sector. There's our ship right there. We got a couple of stars in this sector here with us. And this is where we see like things that are local to us and close by. We have implemented a lot of commands, like moving the different spaces in the sector. And over here we have our little info panel on the right. If I press the F1 key, I get a galaxy map here, or a quadrant map, I should say. Kind of like a abstract section of a galaxy where we can reach. And we have some things to clean up here. So we got the warp command, things like that. All right, we got warp factors, we got shields, we got all kinds of stuff, little dialogue area here and all that kind of stuff. So yeah, and then if I hit F2, I hop back to my sector view. I can see there's some enemy ships. So the point of the game is to defeat all of these enemy ships in the quadrant before you run out of turns. You can also lose if you run out of energy. So most things you do in the game will cost you energy. And you can also lose if you run out of hull. It's also important. But at your disposal, you have torpedoes, you've got shields, you've got phasers, laser beams, lambda beams. I don't know what to call them yet. Some of these things are trademarked, so you gotta be careful. All those little projects, hopefully they won't notice me. Anyway, that's the gist of it. And, yeah. We got a few things we gotta clean up here. The initial quadrant scan state is going to be one thing we want to clean up. Just little bits of polish here and there. And then I want to add some setting screens so we can tweak our game settings in the game and then regenerate the universe and start a new game, that kind of thing. And yeah, so let's get into it. I'm going to open my code. I'm going to go over here. And first things first, I'm going to tackle that first to-do item, which is to get that initial scan state. So we go to simulation. And where do I initialize the quadrant? Oh, maybe it's in quadrant. Yeah, the simulation quadrant. Yeah, initialize quadrant. So we're just going to have to do a quick scan here to update our scan state. So that the bug is, right now that we have is that when I load this up and I go to the map, there should be an S somewhere on here as our starting galaxy, our starting sector. Because we recently changed that where we just finished up all the procedural generation stuff, so all of the quadrant data is like populated randomly, including the player's position, but the current sector you're in should be already scanned. And it's clearly not, although that one is for some reason. I think that might be hard-coded, maybe? Anyways, we're going to find out. Figure that out. Okay, so the inner quadrant is where we set things up and kick off all that stuff. And in a quadrant is call from initial game state. Oh, the generate quadrant is. Big gen. So the generator is called from there. Init quadrant's used in the generator to get like a default quadrant. That's right. And the quadrant map, we generate that from taking a projection, if I remember correctly, off of the quadrant to get the quadrant map. Yeah, we build these quadrant tiles. What we need to do is I think we just need to call scan quadrant before setting it with the current position, that random position we chose. Quadrant. Player quadrant. Aptly named, probably confusingly named. Quadrant. And that returns a quadrant, so I think that should be fine. Let's kick up our builder. So we use the stack tool for building. We're just going to use the test runner, and we use fast and file watch as usual, just to get a constant rebuild as we're going. Take a little water break. Check what's up with chat. Hello, LambdaTrek. Yeah, this is totally a white paper. No, contrary to popular belief, Haskell's not a white paper language. I believe there probably are a couple of white papers every now and again written about Haskell, but it's usually, how did we shoehorn this into a production grade compiler? No, I'm not a researcher. I don't know anything about that stuff. I just make programming. And this game. So let's see. Yeah. So if I hop over here, we should have an S on the map, and we do. There we go. So our initial scan state's set there, and it's right. There's just that. Although I think I want to update the scan state because that should get rid of that. Checkmark that thing. We use the LRS. It's the same thing where we can run long range scan, say 1-1, and it reveals that tile. I don't know why that's not rendering right there. We do the scan quadrant function. We take the current quadrant scan state of the quadrant. Yeah, okay, that's probably why. There we go. Okay. So the other part of this is going to be going into state. So the other thing is when we generate the quadrant, that's just procedurally generating the bit of the universe stuff, the simulation stuff. And init quadrant here sets the quadrant scan state to this. Which is not right. So we need a blank non-singleton one. I think we could just do empty. Which means starting coordinate's not used. Probably don't need it. Oh, we don't need it at all. Okay, so we can get rid of that completely. This is going to break a couple of things, but we're going to fix those. In quadrant generate, probably. those. And we don't even have to pass that through there either. Get rid of that as well. And we build again, so that's good. Although I'm kind of somewhat surprised. Yeah, no, that shouldn't be working because that changed. Odd. Maybe I just move it too fast for the file watcher. Okay. A little better. Okay, so that initial one's gone there. That's good. Now I think I just got to look at the tile. How we're generating this tile. To fix that part. So quadrant tile is like just a bunch of flags for when you scan that sector from the quadrant map, just to give you some information about what could be in there. If it has enemy ships at all, or a player ship, or a starbase, basically. Our render quadrant data probably looks like where we, yeah. Ah, okay, so that should be there. That makes sense. So it doesn't have any stations there, I guess. The other ones just show spaces. I wonder if we should just make that a space too to be a little more consistent. I think that'll probably look a little better. Yeah, it works on mine, but not on the others. So it's unscanned. No, I think having an indicator that like it hasn't been scanned yet is probably good on the map, actually. Yeah, that makes sense. I'm gonna leave that. That's good. That's no bueno. Force a rebuild on that. Yeah. Yeah. So when you scan it, that way you know which ones you have scanned already. It's out of range. LRS, whatever. We're close to 3.3, so yeah, nothing there. And then if we warp over to 3.3 and go to our map, it's just a star. Cool. So let's create a little commit, bump that up. This will fix initial scan state. Also tweaked the quadrant map rendering. Means unscanned. Otherwise, render the scan data. Cool. To do, knocked off. Boom, boom. Okay, I think we have a leftover to do, if I remember correctly, to implement that. Available space function. It's currently sitting as a little time bomb for us. So we go to simulation, available space. Available space. That might be in sector. Nope, it's here. Okay, it's not undefined, but it's not actually implemented. We've just been kind of super careful about it. Not really super careful, but, you know, careful. Okay, so, quadrant. Available space. So the first argument is the quadrant. Second one is a sector chord. We want to know if there's space available in that sector to put something. I guess is the question. And technically this should never return false if we're doing things properly. As I recall, we kind of wanted to have that invariant that there is always at least one space. But this question should also answer the available space should be false if there's only one. So I don't think we use that for placing the ship. We're using available space as a guard for placing other things like the stars, the enemies, the stations. Other the player ship. There is always one space reserved for the player. Okay. So in order to get the available space, we have to get... We know the size of a sector. We can get all of the data, all the number of elements for each of those other objects, and just subtract those from the total space. And I think that'll give us the difference. And then we can return true if it's greater than 1. Okay, so ship, no enemies, ships, something. We can do the num stations, something, and num stars, something. And if we know that, then we take the difference of total sector size, which I think is 15 by 15-ish. No, it's 14 by 14. Something like that. I'll figure it out in a minute. We take that minus the sum of non-enemy ships. And num stars. And if it's greater than 1. That's our equation. We just have to fill in these holes, and then that should work. And I think we have the function we need in sector, hopefully. We have a live enemies. Sector, enemy. Sector enemy ships. That's an internal. Yeah. Oh, we already have this function. We just need the length of it. we also have the function. We just need the length of these. So we got to get the sector from the quadrant. Once we have that, then num enemy ships is list enemies on the sector, and we just take the length. We're using lists here. They're not going to be that big. Okay, we've got that part filled in, and we just need to fill in this little bit here. And that's in quadrant. Render, like get sector. Yeah. There we go. Boom. Okay, we should be back to a green build. And everything should still keep working. Test pass. Survey says. Boom. Boom. 2, 3. And 3, 2. Nothing around us. There's some enemies over there. Shields up. Cool. So that's that. For some reason I ran out of energy, but boom. Let's just make sure that we implemented available space properly. Pretty sure we did, but doesn't hurt to add a little testy test. Little sector. It's kind of quadrant type stuff. Sections per quadrants, let's add one. Quadrant. Boom. Available space. Let's see. Given a empty quadrant, should be true. It's kind of a silly one, but sorry, an empty sector. Oh, pardon me. There we go. And our test initial game state as in a test quadrant. with a single star in pretty much every quadrant. And some enemies in the first quadrant in the top left. And a station in every quadrant. Okay. And mostly empty sector. Right. And that, let's see, available space. We just do it like this, available space, with our init quadrant, initial quadrant, game state quadrant, something like that. Could be true. It's trivial. But an interesting one is that given a sector with only one space, could be false. We'll have to do something with the doohickey. Mostly full sector. Something. And then available space of that. Should be false. Okay. Then, so you could probably just take in a test quadrant. In the first case. And we'll just do 0, 0. That one should be true. And then this one, we have in a test quadrant, 0, 0, we have to do something with it. Let's fill up 1, 1, say. I'll test fill sector. And we'll put that, say, here. That's going to take a coordinate like this, a quadrant, and just return a new quadrant. I don't think we have like a set sector. But we could just fill it up with stars. In fact, if add star is implemented properly, we should even be able to fill this up like with using more sector coordinates than are available even, and it'll maintain the invariant that we have that one available space, and this would still return false, as our test asserts it should. So we have the sector coord. We need a star coord to add for stars. What we'll do is we'll generate the star coordinates from all the available sector coordinates and just keep adding stars until we... Now 15 by 15, not 14 by 14. So I think this might actually fail because the way I implemented it was 14 by 14. Well, let's see it fail though. Okay. So let's do this with. Well, I could do this like with a quick recursion. Okay. Alright, we're gonna recur on a list of sector coordinates. Which will be like, we'll just generate in line here in the test. 0 to 14. Y. Let's go to 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. No, that'll give us a diagonal. No, that should give us everything. Okay. And then we pass in sector chord, the quadrant. Pull this a little over to the left here. A little space, and be a list of stars to add. Our sector coordinate, our quadrant. Returning a quadrant. Okay. In the case where you have no more stars to add, then we just return the quadrant. Call it Q here, just a helper function. Otherwise, we've got another star coordinate to add. And we have a sector chord, and we have the quadrant Q. Just call it SC. Okay, then we can go add star, and we give it the is it star chord first, sector coordinate in the Q. And then we have to recur on go. So called stars, same sector coordinate, and the quadrant. Oh, that's going to return a maybe. Let's case match on that. If we can't, then just return Q. Otherwise, we have Q prime. So then we recur on go with stars, SC, and Q prime. And we do everything properly. Quite. Just name shadowing, it's not a big deal, but what's the real problem? Yeah, not in the map. Okay, so we have an indexing issue there. Go to the bottom. Why is this one happening again? Oh, not again, but this particular map.bang is happening because oh, probably because we got the arguments here reversed. There we go. Oh. Cool. I thought that wasn't going to be right, but it was. Let's make sure that that's true. If I go to available space... So I think it's supposed to be 15 by 15. We're not doing sector coordinate. We're passing that one through. There should be 1-1. Let's see. Equal to 1? That one fails. It's not equal to 1. Okay, if I switch that back to 1 and we just do, let's take out num stars as a term from our equation. And then it should, our test should fail in this case, I think. No. Yeah, available space should be false. It is false. There is no available space. Okay. Well, add stars probably, I guess. Just adding the star. Because we got it wrong. Oh, we're using add star. We're taking it out of it. There. Sorry, num star should be removed. Let's remove. We fill this up with less, fewer stars. Okay, now we falsified it. So this is saying that if we fill this with fewer stars than there are available spaces in the sector, so there definitely should be available space in there. Right, we got true, so that's right, but we expected false, okay. We go 13 to 13. Should still be the same result. Let's go. Okay. We go every possible space. Okay. That's what we... Yeah. Okay, I'm convinced now. Now I get it. Right. And if we made it one more empty space in this, it should be false again. Alright, so if we actually went... Let's bring this up into its own binding here. And... we... we did put a filter on here, like x does not equal 1, and y doesn't equal. So just one of those coordinates won't be included in the set. Oh, sorry, that's not the syntax for 1 equals 1. I'm getting my brain mixed up. In Haskell, it's gotta be a little bit different. Yeah, and then we fail. Okay. Oh, good. Okay, so we did implement it correctly. We got the test in there. We're good. Sweet. Boom. Boom. This will implement the available space function. Sweet. Okay, so next thing we got to talk about settings. We're going to be able to mutate and set the game settings in the game, and then be able to like start a new game or regenerate the universe, that kind of thing, so we can start tweaking our game parameters to like start making it a little bit more interesting and fun. Let's try, sorry, 1, 2, there we go. Cool. So, I think what we should do is go into our UI and create a new UI screen for it. Our UI code is all in UI.hs here, LambdaTrek.ui. Let us create settings screen, something like that. Create it after the game over screen, maybe. This is probably going to be one with a form in it. So we're going to need the form stuff. We're going to add a setting screen. This is going to be a stir. Settings. Probably don't need the parentheses around it. Okay. So we're going to need to get a new game state screen. That's what we case off in the UI here to show which screen to show. Hop over to state. Game screen. Settings screen. Okay, that builds again. We're all happy dappy. Wonderful. Super spectacular and great. I forgot to take the focus off my test. I'll sneak that into this commit. It's all good. And then we need a way to switch over to it. So back over to UI. And we have. Oh, this is just the definition. In app. This is where we'll handle all the key events and stuff. Input, output, and that sort of thing from the terminal. Okay, so kfun 2, we'll do kfun 3 to get to the settings screen, I guess. Haven't really thought about it too hard, and I just thought about it now, and that should be good enough. Do get the state, and then we modify it. With this handy dandy little function. And we're going to set it where the game state screen is now going to be a setting screen. And that'll probably compile. But it does. And if we run it. And press F3. Oh, we're in the settings screen. There we go. Let me flip around. Whee. Wonderful. Progress, add a settings screen. Okay, now we need to do more form stuff. You may recall from when way back when, many episodes ago, many streams ago, we did the command input. We had to have like a data structure where to store that form data for it in order for us to use it and stuff. And I think we just put it right in our game state. Command input. This little string here is what it uses. But I think we're going to need something a little bit more robust for the settings because we want the game settings to be a part of that. And we have those. Where did I put them? Find them. Did I remove them? No. What did I do? I have them somewhere, I swear to God. Where'd I go? Because the quadrant generation stuff used. Game config, that's what I call it. Okay, configs. Dang. I'm not good at naming here. LambdaTrek.config. Okay. That's where I put them. These guys, these cats. When we regenerate the game world, it uses a game config to pass in all of these parameters. And I want a form that we can change these. But I think also we should probably pull in more config stuff in here. But I feel like this should be good enough. If we can get this going, that would be fine. Okay, so let's see, how are we gonna do this? Let's look at the UI form. With the little widget. New form. I think that one comes from the library. Not form. Interesting. Command. Palette. Form F. Okay. And that is made an app. At the top level. At the top level. I think I need to do a little bit of reading. Now we're going to do subform stuff. Run brick. Okay, brick. Go to the user guide. We're going to learn more about forums. Okay, a form field state accompanied by the fields that manipulate it. Okay, the idea is that some record field in your form state has one or more form fields that manipulate that value. This data type maps that state field using a lens into your state to the form input fields responsible for managing that state field, along with a current value for that state field and an optional function to control how the form inputs are rendered. Most form fields will have just one input, such as text editors, but others, such as radio button collections, will have many, which is why this type system supports more than one input corresponding to a state field. It's kind of what we want. The only thing is I would only want to render it when we're in a particular state. So always render the command palette here. Those two states. Kind of redundant, but it's there. Command arrow widget. And render form is the other part. I think that comes from the library as well. So I guess we have to construct a new form to pass in, maybe. How do we have multiple forms? Got a bunch of pre-made ones, that's nice. I have multiple forms. Okay, so to use the form, you must include it. Yeah, we know that. We've done that. Okay, so let's check out this example. Maybe they have one there. I'm guessing maybe that we're gonna have a way to, like, maybe we have multiple forms that just map to different parts of the state. Just like, how do we know which one to render at the moment? Examples, form demo. Name. Different names of the different fields. Okay, so maybe we give it a name. Alright, so just like us, we have a user info, construct a form with our state in it. So this will be a game state for us here with a name. So this is only doing one form at a time here. Only one. No. Progress bars, padding, list VI, list hello world demo, file browse. That might have multiple forms, right? No. Okay, this might be promising. Input 1, input 2. Initial state, map the app. Maybe not. Okay. Maybe it's a name thing. We're gonna have to figure this out. Let's try, like, make, I don't know, settings form. Game state. Form. Game state. Some name. Right? Label. Yeah. I'm gonna borrow that. Sure. And we're gonna go new form. Yeah, we'll do label. It's our first field. Let's just do one for now. Let's just do num enemies. And pair it with edit. I didn't see an integer field there or a number field. God, GitHub is getting so slow these days. It's ridiculous. Reveal. No. Yeah, so checkbox field, render checkbox list field, radio, render radio, edit field. Or if you'll be using an editor to edit the text representation of value. Probably not what we want. Password field, no. Yeah, so we'll just use like a text entry one for now. Just to get things going. Just to see if this even works. So we don't have game state command input. We want the function here should be a lens into our thing. Something there. Oh, that's the name of the thing. We'll give it a special name. An initial. That was just L. Oh, that's the. Just one? I don't know, something. Okay. Yeah. Yeah. Okay. So we're gonna do. I guess we're gonna do settings field. Oh, maybe it just needs to be num enemies field. I don't know. I'm just going with the flow. Yeah, one for now. Just do one. Okay. And where are we going to put this? Let's go over to state. Pop it over here. We're going to do like a game state settings form. I should really rename it from settings to config. Maybe I'll do that while I'm going here. Game state, game config form. Something like that. Now, if we do it this way, that form will manipulate this in the game state through the UI. And I think that'll give us a chance, perhaps, to use like a trigger function to like, okay, apply these settings. Configs. Start getting used to calling them configs. So I guess I will add that to config. Game config form, we'll put it over here, why not? Game config form, num enemies, MMEs. Num enemies per sector. And num stations. Show. Hey, tech support, what's going on? Yes, it is a Haskell game dev stream. Welcome. If you're... do you program in Haskell or no? And if you don't, are you curious? Okay, we don't build yet of reasons. I got a hole there. I got to put something in there first. That one's known. And then we have some init code that needs to be updated. No problem. Okay, so this lens is going to be the composition of getting into Haskell for the last few months. Cool, cool. Awesome. The journey begins. Yeah, so it is pretty decent for 2D games, for sure. We did a project before this one where I was kind of curious if it would be feasible for like arcade-ish games. And it is. You know, a lot of people say, oh, you can't do that with garbage collection, but I mean, I've done pretty intense arcade games in languages that have garbage collection for years, and it's fine. And we did use SDL for that project, yeah. It's on my GitHub. Hop under, let's see. What was it? It was Asteroids, I think. Yeah. So nothing super fancy with this one. Just like the most pretty ugly Haskell too. Very vanilla. No real fancy libraries or patterns or anything super advanced. Very, very basic. Just to see if it was feasible. So I think this could be a lot better. And if I was to make like a more serious like arcade style game in Haskell, it could definitely be, I think this proved to me this could definitely be done. It could be fast, because I think this could be faster. And yeah, and there's already precedent for people making Haskell games and putting them out on Steam. And I think they open sourced their engine as well. What's Dragon Ruby? How would I find out that out? Dragon Ruby. Tell me. Ah. See, yes. Cool. Yeah, this would be dope. And if you can get Ruby, if you can use like Ruby for scripting this stuff, it'd be pretty nice, and not like a huge roadblock for a lot of games. You could do it easy for Haskell, 'cause yeah, I bet. So I know some coworkers I work with at work. We're all Haskell. A lot of us are Haskell programmers. So we have all a Haskell backend, and they're also doing game dev. And they did a lot more than I did with the with their engine than I did with my Asteroids clone. And they're using like an effect light framework, like effects and like Haskell effects framework, and all kinds of really high level libraries you think could not be performant, but turns out on more recent versions of GHC it really is. It's coming along really well. I do. I am fortunate to do that. Yeah, that's the way I started. I used to just write little tools for myself, and then I found a little out-of-the-way data project to use Haskell on. Deep in the back end where nobody would really care about it, and just provide a little value. And it was good. Anyhoozle. Yeah, so Haskell game dev, totally great. Right now we're using a terminal UI library, so not a huge... pretty great use for Haskell there, actually. Really easy. Yeah. You can get all of that stuff in Haskell, for sure. Okay, so multiple forms. Yeah, so I gotta put my lens in here. This lens is just gonna let the brick library like focus in the part of my game state that it wants to change with this field. So the lens library doesn't have to know anything about how I structure my state. I can just get a lens to manipulate it, which is kind of cool. And I find a lot of Haskell UI libraries tend to rely on lens for this reason. We also did like a kind of incomplete, but a game engine using more of a graphical UI library that's kind of built on top of SDL as well. And it uses lenses a lot. So I'm learning not to fear the lens. Although when I was beginning in the first few months, like you were tech support, lenses seemed very scary and were for a long time. But they become very useful later on as you learn them. Right, so composing lenses together. Dumb question. No dumb questions. They're all good. They're all decently good questions. Dumb answers though, so no guarantees here. But I've heard of lenses being tedious to use in Haskell. They're totally easy to use in TypeScript. Am I missing something? Maybe? I'm not sure what tedious means, but they haven't been tedious for me. At least in this project. They seem quite powerful. They can be very powerful. And I haven't used the vast majority of what's available in the lens library because it gets pretty arcane pretty quickly. Difficult? Yeah. Difficult it can be. And it's only difficult because it's so unfamiliar. But once you get to a comfortable place and you're ready to start using lens, give it a shot. You won't have to for a while, so don't rush it. But some of the type errors you can get out of it can just be outright. Which is unfortunate, but it's the way it is. And eventually, once you get brain damaged enough by Haskell, you can just kind of deal with it. And by brain damaged, I mean experienced. You know. Right, so we actually have to make lenses for these things, of course. So I'm going to need to do that first. Add template Haskell. And lens library I'm using is micro. I think it's micro.lens.th. I'm gonna have it right. It was like data.micro.lens. Yeah, I can't remember the import for it now. I'll plot ahead because I'm smart. Yeah, that's cool. I love me some fear improving and super dependent functional types. Lens.micro.th. Okay. So not super tedious. Nice things, they just compose. And so the reason why I really like them is because they're getters and setters, ultimately. Like originally, that's kind of the impetus for them. So the simplest use of them is like they're getters and setters. But you can define your getters and setters for one record, but when you have nested records, where you start nesting types like this, they compose well, so you can have arbitrarily deep structures and have an easy way of getting and setting values within them. That just composes nicely together. Not a lot. You're not writing a ton of getting and setting code. Yeah, optics are dope. Super dope. Okay, very sick stuff. Love it. So we got those generating. So template Haskell is just going to generate all that code for us. We don't have to. I compiled that. Yay. And then we go to UI, and we can config. I think composition with them is generally backwards from how you would expect normal function composition to work in Haskell. So I think we actually have to go deepest first when we compose them. So I might have not named these well. Have to import that. Bang, bang, bang. So how are you finding the leap tech support from TypeScript to Haskell? Have you been doing a lot of functional programming in TypeScript already? I might want to import a qualifying LambdaTrek. LambdaTrek config. Let's go. Okay, I did poorly name them. Is it game config form, maybe? Okay, that is. Cool. That's awesome. So that gave you a pretty good leg up on learning Haskell. Like, did you find you were kind of breezing through the initial, like, Haskell tutorials, or? That's super important. I think everyone stumbles on that at first. Everyone starts, I find, like, I did this, and I know a lot of other people who have as well, because, like, we hire a lot of people from outside of Haskell into our company as well, and kind of teach them. Because we hired up a lot of really good Haskell developers, and the pool for, like, Haskell experienced people is pretty small. So we hire outside the field quite a lot, and a lot of people do, like, the same thing. They want to learn everything all at once, or they feel like they need to know everything in order to grok Haskell and start getting it. But I think you can get into it a little bit more piecemeal than that and get a long way without even touching a lot of the more complicated monad stuff. At least you can have an intuition for monads at first, and then you can fill it in with, like, knowing and stuff. But I also find once you know it, it's really almost impossible to explain it. Everyone tries, but just doesn't work. So then we can do game config. Let's go to the state as we want. Game state. Maybe it's game config form. Now that one's going to be a type because we couldn't match into the text, because right now I'm just kind of hacking things together. So I'm going to make that text. We're doing num stations. Yeah, it's true. It's good to try to explain it, because, like, that kind of, like explaining things internalizes your knowledge as you're learning things. And I find if you can explain something clearly to someone and they get it, then you're good. You probably understand what you're talking about. But monads, it's like a lot of pure maths, right? Like, pure maths is also really hard to explain. I find, anyway. I know other people are really good at it because, like, teachers have been doing it for many, many years. I don't know. I know how to use it, though, sometimes. Really? Monoids? I found those, like, monoids and functor, I found frustratingly, like, almost disappointing to learn. Because the concept is, once you understand it, it's so infuriatingly simple. But when you're starting to learn it, it seems like this big word, functor, and it's gotta be hard, and it's gonna be category theory or something involved here. And don't get me wrong, you can learn about those things from it, but the concept itself on its own is really, really easy to grok. Yeah. Yeah, so I've been trying to, like, avoid front-loading definitions for that audience, and I wish more Haskellers were mindful of this. It's because, like, I appreciate... There was a talk from Simon a bunch of years ago called, like, Escaping the Ivory Tower or something, and I love the justification for sticking with the names that inspired these concepts in Haskell, which are like the mathematical names. Because you can go to a vast resource of textbooks out there, and like, there will be the word functor in there. And it should be analogous to the one in Haskell. And so the idea was, like, don't confuse people by making up new names for existing concepts. And I think that's great. But there's a certain audience of people that come into Haskell regularly who don't have the mathematical sophistication to already be comfortable with names like this. And so it seems weird when you throw in these definitions and these names, these types and stuff everywhere. There's already a lot to learn as it is. That thinking you're going to start a beginner text for that audience by front-loading it with a bunch of definitions like that is, I think, a little bit extra, a little too much. But I think there are some resources out there that have kind of cut back on that a little bit and take a little more pragmatic approach to it. So I don't have text and scope. Just gotta bring that in. Anyways, that's my rant for the evening. Hope you liked it. Text. Yeah. The thing is, like, a rose is still a rose by any other name. Right? So the mathematicians got there first. Big deal. We can learn to live with it. You know, as programmers, we're taught to think like naming is this super important and super hard thing. And it's not that part that they're talking about with naming. It's like just being consistent with naming. That's hard, I find. But like, a monad is a monad, and you can call it something else, but it's not going to make it any more clear. So I think my advice is always just learn the intuitions, learn how to use it. Learn the definitions in time once you've got comfortable with the notation that they use. And then you can read it and you can understand it and go, oh, now I can't explain it. Damn it. And then you can watch other people on the internet write these tutorials and try to explain it and go, I feel your pain. Okay. That's text. Nah. Ooh, I have not seen that one. That's an IO exception. I mean, that's, I think, an easy one to fix, but I haven't seen that before. That's weird. Oh, edit text field is demanding... No, I changed the type of text. Okay, maybe the GHCI and the running in the background behind my Emacs isn't caught up yet for some reason. Or other... Okay, this one's more important here. Let's get our test runner building again. And that's because we updated game state. We just have to pass in kind of like a game state. Game big form. I'm using the init convention. I'm gonna stick with that. There we go, init big form. this actually up here. Yeah. And I'll change that. Yeah. And this will be. We don't have overloaded strings in this module. I should just have that by default everywhere. So I think you mean us at work, where I work. We use Nix and Haskell, Nix Haskell or something. Yeah. That should be there. And we're building green again. Okay. So we're not using this in the UI just yet. So we have this mux settings form to construct the form widget. I don't know how it's going to pick which form. If I go to add this to... Maybe I'll be delightfully surprised if I just look it up and see what happens. So over here, at the entry point to the program, we construct the initial state of the game. And we use this makeForm function to set up the initial state of the command field input form that we use. So the game currently looks like this. And this over in the bottom right, the command palette here, where we input our commands, is a form. Right. And that works kind of nicely. If I go over, I can fields up, and that kind of stuff. And the thing is that when it's rendering the UI, right, I get the I get a value of this type here, form game state ename. And then I render the different screens, like the sector screen. I render command palette from F. And F is that form game state ename thing. And if we go to command palette, we create a error widget that might be empty. And we render that and we compose that with our render form app here and wrap it in some centering and stuff. The render form, right, just renders form F. Right? But right now, I know when I go make form here, that it's going to create that form that we define here. I have this other function, mux settings form. And I want to know, I don't want to display it on every screen. I just want to display it on the settings screen. So I'm like wondering what the heck's going to happen. How the heck do I do that? Because I don't think there's a way to combine forms, unless there is a way. I just haven't looked yet. So form field, state form. There's a sequence of input fields. Right, okay. Alright, so it's just one set of widgets. And I don't see any other instances like that would let us combine forms together. And this is kind of like passed all around all over the place in the UI. Right. Modern screen is a form game state. Game over screen, form, game state. So how do I render this thing? Render. Oh, GitHub, you're terrible. Look how slow that is. It jumps to a thing and it like takes a whole like second to render. Ugh, brutal. Anyway, I shouldn't complain. But I should. Right, so it just takes one instance of a form to render. So I wonder maybe if we can store a value of form in our game state. Or we can use this name, this N, to fix the one we need. Maybe that's what's meant to be, the way it's meant to be used. So I think maybe this should be in big form, not settings form. I'm trying to fix my naming. Like this. It's actually number of stations. I can't say which name, except in the fields. So I don't think that's a way for us to distinguish multiple forms. Yeah, so new form. Yeah, the list of field constructors, yeah. Initial state. Yeah. It does return a form SEN. And those form field states have to have the same name, the same N. Okay, so that might mean that that's the way we could distinguish multiple forms. So if I don't have this, but we just plop all of our fields together. Hey, Chromo Sundrift, how's it going? Welcome to the stream. I'm just gonna like put some random garbage in there. See what happens. Edit text field, game, and we're gonna do the, actually I'm gonna copy that whole lens over from my commented out. Woohoo, yeah. I'm gonna give it the different name type there. I don't know. Maybe just one? Maybe nothing. Maybe I should put nothing in there. Okay. I'm not gonna compile yet because I did not type that in right. In big form. Chromo Sundrift. Are you a Haskell programmer as well? Game developer? Or just curious to see? A voyeur of Haskell game dev programming. Okay, we're back to green, so that at least compiles. Probably stupid, but we'll see. And totally dumb, because I totally forgot. Yeah, missing field and state. Game config form. Cool, me too. Ah, yes. I've been doing it for a few years, but I'm still much more experienced in other languages. And I may get more Haskell experience than other languages before the end of my career, if I'm lucky, and I stop programming them now. Maybe. Cool. Do it for back 40 for fun, or are you learning for a job? Okay. So we got our... So it's going to render everything. Cool. Okay, so that was clearly not the path. Although I'm curious what the nothing... the just parameter there is all about. Mess around, just change that to nothing, see what happens. And I'm running low on time for the stream tonight, so I might have to do a little research for next week's stream on this. Okay, that doesn't really do anything. So the key is not to bundle all your labels together into one giant form. We do need multiple. But I don't know how we're going to combine them together into one application. Still, this is the missing piece. Okay. Well, we have our settings screen, not populated by anything yet, but I want that form to show up there. When I hit my button. So, maybe one approach we can try is storing a form in here. Getting it out. But the form object needs the state as well in the Brick UI library here. So I guess that type would be our game config form. E. I don't have an E. I don't know what to put there. And a name. E is your application's event type. We don't have that in the game state, so this is like kind of... This would be kind of like tying our state to the UI a bit, if we did it this way. Yeah, I'm gonna have to do some research to figure that out. But we made a little progress on the game tonight. Not too bad. So I'm gonna just, let's see, back out of this stuff. Yeah, back out of that, back out of that. I'm gonna leave, nope, back out of that. Back out of all this. I'm gonna stash this for now. Maybe we'll get to it next week. Or I'll abandon it when I figure out how it works. Multiple form madness. Library issues. However, I'm gonna rebase it and rename that. It is kind of work in progress, but that's okay. It's bare bones and doesn't do anything. Yet. Okay, so just a quick review for those of you who just tuned in. This is what the game looks like so far. Right? It's a roguelike game, kind of based off of Trek. It's Trek inspired. And so you're a commander of a starship of some kind. That's the little S here. This is a little sector screen, which I'm going to tweak and make look a little better, but this is what it is for now. And these are enemy ships. The goal of the game is to take out this invading force of enemy ships from the local quadrant before you run out of turns. At your disposal, you have torpedoes, you have beams and shields and a hull and all this sorts of stuff. This is all implemented and working. So combat and all that stuff is already there. Movement and all these sorts of things. You input your commands here by typing your commands. And then you have like a little combat area, a little dialogue area. So different crew members will tell you what's going on inside the ship as it happens, turn to turn. So roguelike in that it's very like you take a turn, enemies take a turn, you take a turn, enemies take a turn, that kind of thing. All right, so the shields are holding. We took a little damage. It lowered our shield strength a little bit. Took a bit of damage to the hull. You can't fire your lasers through the shield. You have to use torpedoes in that case. But anywho, that's all implemented. We have a quadrant map here. So this is the current sector we're in right now. And these are like little tiles that show you the scan state. We haven't scanned this one yet, so we don't know what's in there. You can use your long-range scanners to scan other sectors. And then we found there's a space station there and some more enemies. All right, so we could warp over there, take out those enemies, dock at that space station. That's all implemented too. We're just in the middle, and this is all procedurally generated as well, so the universe is different each time. And we're just in the middle of implementing a settings screen, so you can kind of tweak the game parameters and like regenerate a new universe and start a new game. And polishing things up and getting things ready for making version 0.1. Future plans for this project. If people like this project and want to keep seeing it develop even further, I think we could make a cool cross-platform release that is not terminal-based and try porting this to a graphical pseudo-terminal so that it gets like a consistent rendering on multiple platforms without having everybody to run it inside like a console of some kind. And yeah, that would be like the next phase of it. But 0.1, playable. If you can run inside a terminal, you're good. And I think that would be a good pause moment there to see if we want to do any more. So I usually run these streams once a week on Tuesday evenings at about 10 after 8 in the Eastern time zone. So you can join me then. Or if you like subscribing to get notifications to remind you of these things, you can do that here on Twitch. If you're watching my VODs on YouTube, you know what to do there. And follow along. You'll get those email notifications when I go live or when I upload a new VOD to YouTube. So do that. Helps out. Lets me know that people are watching and that sort of stuff. Just fun. And what else? Code for tonight. I'm going to push that up. It's on GitHub. So that, you know, Microsoft can analyze it and use it in their new AI bots and all that stuff. And you can use it too, because it's open source. It's here in LambdaTrek. I'm Agent Ultra. GitHub.com/AgentUltra/LambdaTrek. I'll just post that in the chat. I don't know if I always do that, but hopefully I do. Bang. And you can check out the code there. Hack it and do whatever you want with it. You can follow me, of course, on the Fediverse, on the Mastodons, whatevers. I'm on the types.pl server at Agent Ultra there as well. And if you go to the link above me, there's a link to a Discord server. And there are lots of cool channels of other streamers who are streaming in other similar languages to Haskell and various other cool things, and including a channel for the stream. So if you're watching it from a different time zone on YouTube, or you didn't want to ask a question on stream, you can ask it there. We can chat about whatever. Your projects, this project, anything you feel like. And that's it. So let's go raid somebody. And we'll see you next time. Let's see who's online. Ooh, Transwrite music's pretty sick. Makes some amazing music. Let's go check it out. And I will kick off the raid. Okay, been a pleasure. May your monads be free and your types always check. See you next week.